So topic 25 is more sketching, specifically the square root function. Now, as mentioned in other topics that involve sketching, you all it is just using function transformation. So this is probably the third, fourth, or fifth time you've seen this, but you can never see this enough because this is truly important, function transformations. So you have to understand that by altering a function's equations, you produce changes in the graph. So if you were to add a number to a function, you'll move the graph up. Subtract a number from the function, you move the graph down. Add directly to the x, you will move it to the left. Subtract directly from the x, you move it to the right. If you multiply the whole function by a number, you're going to stretch or shrink the graph depending on what you multiply by. Multiply by a big number, you stretch it up. Multiply by a small number, you flatten it out. If you multiply the x directly by a number, it sort of happens backwards to what you expect. Multiply the x by a big number, you shrink it inwards. Multiply the x by a relatively small number, you actually stretch them out. Lastly, you can actually flip graphs around. If you make the whole function negative, you'll flip him over the x-axis, but if you just multiply the x by a negative, you'll flip them over the y's. So in order to sketch complicated looking square root functions, you just have to know what it originally looks like, and then you, well, transform it. So let's take a look at the parent function of the square root function. This function here, without any bells and whistles, no adding, no subtracting, no multiplying, let's see what he looks like. Well, the best way to investigate any new function is with an XY table. However, I'm going to be a bit strategic. Since I know this is a square root function, I'm probably only going to pick perfect squares. So let's pick 0, 1, 4, and 9, right? Because we know if we plug these numbers in for the x, that is to say take the square root, we're going to get 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. Notice I didn't bother plugging in negative numbers because over the field of real numbers, we cannot take a square root of a negative. So let's go ahead and plot this guy. See what he looks like. So it looks like I have to make 10 tick marks here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. And let's just plot it. 0, 0. Oh man, my tick marks are not even. 1, 1. 4, 2. 9, 3. So it looks... Ooh, that's bad. So it looks something like that. It's sort of like a lazy swoosh upwards. And that should sort of make sense because the square root function, well, usually makes things small. So when you take a square root of a number, it shrinks it down, yet still increasing. So if I want to sketch more complicated functions, I just have to remember this basic shape. A square root function will start at the origin and have an upward swoosh motion. Also note that at the origin, the very next point is 1 to the right and 1 up. We will utilize this to our advantage later. So let's take a look at a more, quote, complicated function. Suppose I ask you to sketch, f of x equals the square root of x plus 6. The first thing you want to do is read the transformations presence, up, down, left, right. So in this instance here, we have to be able to read all of these transformations here. Well, there's only one transformation I hope you guys can see is the plus 6. And we should know that this plus 6 moves left 6. That's it. That's all the hard work you need to do. The rest is sketching. So let's make some tick marks here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, knowing that we originally always start the origin, what I need to do is listen to the transformations and move this point. Well, he said move 6 to the left, so I'm going to move 6 to the left from this location. 1, 2, 3, 4, 5, 6. That's where I make my point. Well, I know he's going to be this swishing shape, but let's try to be a little bit accurate. Remember how I said in the basic picture, the very next point is always 1 to the right, 1 up? Well, from this move point, I should know that the very next point is 1 to the right and 1 up. And then go ahead and approximate your swish shape. That is the graph of that square root function. So that's basically it in a nutshell. Just to sketch a square root function, you have to know the basic swish shape, and you have to be able to read the transformations present. Let's just do one more with all the bells and whistles. Let's try to make it as complicated looking as possible. Let's go ahead and sketch, I don't know, f of x equals 2 square roots x plus 3 minus 4. Lots of things going on here. So the first thing I want to do is identify the transformations. So again, this is you either know it or you don't know it. There's nothing to calculate or figure out. So you should be able to look at this equation and go, oh, that's left 3. That's down 4. And this is a vertical scale by 2. More on that later and how that affects the graph. But once you identify all the transformations, that's the hard part. Next, just graph it and listen to the instructions. So let's make a coordinate grid. Let's make some tick marks. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So remember, we typically start the origin, but then what you have to do is listen to your transformations. So we have a left 3, down 4. So from the origin, we'll go left 3, 1, 2, 3, down 4, 1, 2, 3, 4. Make a point there. Now, how does the vertical scale by 2 affect things? Well, remember the basic shape. The very next point to the right should go up by 1. Well, if you have any vertical scales, it's going to change that number. So for instance, if I have a vertical scale of 5, instead of going up by 1, you go up by 5. If I have a vertical scale of 1/2, instead of going up by 1, you go 1/2. So your very next point will always go up by the vertical scale. So in this example, since our vertical scale is 2, when I go to the right, I'm not going to go up 1, but rather when I go to the right, I'm going to go up 2. And then you can go ahead and make your stretched up swoosh. All in all, this is a sketch. It's not picture perfect, so it's not museum quality. What will I be grading you on? What will I be looking for? I'll be looking for 2 things. Do you have the right overall swish shape? And do you have the right starting point? But that's sketching square root functions. It's like sketching any other function, sketching quadratics, sketching absolute values. It's just reading the equation for the transformation and moving your starting point. So go ahead and give it a practice.